Let's go on and see if we can figure out another example. First thing we want to do is identify all of the carbons that aren't showing. You'll see immediately we do have a couple of heteroatoms here. I've got an oxygen and I have a nitrogen over here. And also notice again that I am explicitly writing the hydrogen atoms on my heteroatom. Let's go ahead and see if we can't identify the carbon atoms. Remember, we said at the end of each line, unless there's a heteroatom there, at the end of each line we're going to have a carbon, and where two lines meet. So I have 1, 2, 3, 4, 5 carbons here. Let's add in our implied hydrogens. If I look at this carbon, let me just number my carbons here for you. If I look at carbon 5, let's start at the left end, I see that I'm showing only one bond, a single bond, so that means that carbon wants to have 3 more bonds. That means that I need to add my 3 bonds to hydrogen. Next carbon, carbon number 4, is already showing 1, 2, and 3 bonds. Remember, this is a double bond, so that's going to count as 2. If I'm showing 3 bonds, that means that the carbon wants to have 1 more bond. Let's look at carbon 3 right here. Again, I'm showing 1, 2, 3 bonds. One of them just happens to be a double bond, and that double bond counts like 2. If I'm showing 3 bonds, that means I need to add 1 more bond, and that bond is going to be to hydrogen. Let's have a look now at carbon 2. Carbon 2 is showing already 2 bonds. That means that it wants to have 2 more bonds. So I'm going to need to add 2 bonds to hydrogen. And finally, let's have a look at carbon 1. Carbon 1 is showing 1, 2, 3, and 4 bonds. Remember, that double bond counts as 2. I'm showing 4 bonds. That means I don't need to add any hydrogens here. You can see that I have my heteroatom right here, an NH2. If you remember the bonding pattern for nitrogen, nitrogen wants to have 3 bonds. Nitrogen is bonded to this carbon right here and to 2 hydrogens, so that nitrogen is good. Here's an oxygen. Remember that oxygen wants to have 2 bonds. This oxygen has a double bond to this carbon here, so this oxygen is good. That means we're done. This would be our dash representation for this molecule. Let's go ahead and see if we can't write the condensed representation. Starting from the left side, I have a carbon with 3 hydrogens, so I have a CH3. Then I have a carbon with 1 hydrogen, a CH. Then I have another carbon with 1 hydrogen, another CH. Then I have a CH2, followed by a CO and NH2. So there is our condensed formula. Let's see if we can't figure out what our molecular formula is. If we count up our carbons, I have 1, 2, 3, 4, 5. So I have a C5. Hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 1 nitrogen, N, and I have 1 oxygen, O. C5H9O. Let's work a few more examples. This is something here that you haven't seen before. This is a ring type structure. Atoms can arrange themselves into rings. You will see lots and lots of examples of this in this class. And you're going to interpret this in the same way that we've been interpreting all of our other structural representations. Wherever you see the end of a line, if there's no other heteroatom showing or written explicitly, you're going to assume it's a carbon. Wherever you see 2 bonds or 2 lines coming together, you're going to assume there's a carbon. The first thing that we need to do is to identify all of our carbon atoms. So let's go ahead and do that. Well, I have one here, 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 and here. So it looks like I have 6 carbons. Remember that in our skeletal representations, the only things that I'm not going to show you are the carbon and the hydrogens, so I have to identify those implicit carbons and hydrogens. So let's do hydrogens next. We're going to start right here. That carbon has 2 bonds showing to it. I'm going to need to add 2 hydrogens, or 2 additional bonds, and those are going to be bonds to hydrogen atoms. Let's look at this carbon right here. That carbon has 3 bonds showing. That tells me that I'm going to need to add 1 bond to a hydrogen. Look at the rest of these carbons. All of these carbons in the ring, they have 2 bonds explicitly drawn. That tells me that for each of these carbon atoms in the ring, I'm going to have to add an additional 2 bonds to hydrogen. And if I really wanted to be absolutely correct in converting this to a dash structure, I would really need to explicitly include all of my carbon atoms, and I'm just going to do that for this particular structure. I'm probably not going to do that in the future for all of them, but I'll use a green dot to represent carbon atoms in the future. Next thing that we want to try to do is to figure out what our condensed representation would look like. Well, it turns out that rings don't really lend themselves very well to condensed representation because in the condensed representation, remember, you start from one end of the molecule and you list all of the atoms to the other end. And if you have a ring, then where do you start? One thing that you might see occasionally is the prefix cyclo, and cyclo indicates to you that what follows the prefix is going to be in a ring. So I could say cyclo and then include what is in that ring. So I have 5 carbons in the ring, C5, H, 2, 4, 6, 8, H9. And then I'm going to close that parentheses, and this is going to be followed by CH2, NH2. So there is our condensed representation, and if I wanted to figure out what my molecular formula would be, I just add up each of the atoms. I have C6, 6 carbons. I have H13 and a nitrogen. So there we have our dash representation, our condensed representation of a sort. And remember that I can't do subscripts here, so all of those numbers should be subscripts. And we also have our molecular formula. Let's go ahead and try a couple more examples. This one looks kind of like a bat, doesn't it? First thing I want to do is identify all of my carbons, so let me go ahead and highlight them for you. I have 1 at the end, 2 at the intersection, 3, another one at an intersection of 2 bonds, and then 4, so I have 4 carbons in this molecule. Let me figure out how many hydrogen atoms I have in this structure. My first carbon right here has 1 bond showing. That means I'm going to have to add 3 hydrogens. Next carbon, I add 2. Next carbon over, I'm going to pass over this oxygen here because that oxygen is happy. 2 hydrogens and 3 hydrogens on my final carbon atom. Let's go ahead and put them all in. And if I really wanted to be technically correct with my dash representation, then I would have to add all of my carbons. And we'll just do that for this example. So this would be my dashed representation. All of my carbons are happy, and my oxygen is also satisfied. Now let's figure out what our condensed representation would be. Starting from the left and moving to the right, I have CH3, CH2, O, CH2, CH3. Another way that I could write this, since I have 2 of the same thing attached to my oxygen, and these 2 things just happen to be ethyl groups, ethyl, not methyl. We have 2 carbons, so they're ethyl. I could say it's CH3, CH2, and I have 2 of those attached to an oxygen. So that would be correct. Either one of those would be correct. And remember, I can't do those subscripts. And our molecular formula would be C4H10O. Let's try one last example. Again, we have a ring-type structure. So I'm going to have to identify all of my carbons. And again, I will highlight those carbons for you. Wherever I have the end of a line is a carbon, well, I don't really have any lines hanging off. I have a ring-type structure. But wherever I have the intersection of two or more bonds, I have a carbon. So I have one here, 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 and here. So I have 4 carbons in this molecule. I have to figure out the number of hydrogens. If I look at my first carbon, this carbon is showing 3 bonds. I have a double bond and I have a single bond. The double bond counts like 2, remember, so that's 3 bonds, so I just need to add 1 hydrogen there. Same for this carbon, it has a double and a single. I just need to add 1 more hydrogen. This carbon is the same. This molecule is very symmetric. Now let's go ahead and add in our hydrogens, and there we have it. Let's try and figure out what our condensed representation, not so good, not so easy to do with a ring type structure like this. Let's just go ahead and figure out what our molecular formula would be. I have 4 carbons, C4. I have 4 hydrogens, H4, and an O. And there you have it.